We have a problem statement as the disk is rotating at a constant rate of 4 radians per second. That is, omega is 4 radians per second, and that is constant. And it falls freely with an acceleration of 32.2 feet per second squared. So it falls with an acceleration of, let me say this is g, that is 32.2 feet per second squared. Determine the accelerations of point A and then B on the rim of the disk at the instant shown. Okay, so let's start first from then A. So the center here, then it is O, and it has an acceleration of 32.2. I will just apply this equation here. So then I will have A will be equal to acceleration of O plus the acceleration of A with respect to O, that will be the tangential component, plus the acceleration of A with respect to O with the normal component. And that will be, again, if I write in a full form, the first one is alpha into R A with respect to O, that will be this one, that is R with respect to O, and then minus the omega squared R A with respect to O. That is the equation. And then the first one is A with respect to O. So let me write these equations as a coordinate system that has a y-axis and an x-axis. Firstly, let's start with the acceleration AO. That is 32.2 feet per second squared, but it is downwards. So I will just write this one as negative 32.2 j hat. So it means that it falls. It is opposite to the direction of y. Then alpha in cross product with RA with respect to O. So then alpha is, if you remember the equations, that was d omega by dt. And then here that it says the omega is constant. So that is d of 4 with respect to t, and that is 0. Okay, so omega is constant. So with that in mind, we can leave this one out. So plus 0 minus the omega squared, which is 16, times RAO. RAO, you can see it is 1.5 feet, and it is to the up direction. So it will be 1.5 and then again the j direction. Okay, so if you do that calculation, so you will see that 16 times 1.5, 24 plus 32.2 is 56.2. So negative 56.2 G. So it means that A is in downwards direction. Y. So let's write this one as negative y with magnitude of 56.2 feet per second squared. Okay, now comes the AB. That will be the same formula here. So let me just write the full form. That will be alpha cross with R B with respect to O minus omega squared R B with respect to O. Okay, the first term, again, it is 0. I mean the second term, this is 0. Then this one is again negative 32.2 J. then last term, that is 1.6, sorry, that is 16, and then this one comes. So that is our, this is our b with respect to O. You can see it is in positive x direction, so that will be 1.5 I. Okay, so it means that AB will be equal to negative 32.2 J minus, it was 24 I. Okay, and then it means that, so then let's do, so this will be 32.2 and then 32.2, and then we will have 24. Okay, and then this will be the acceleration AB. That is the acceleration of B. Okay, this is acceleration B x component. This is acceleration B the x component, and this is acceleration B the y component. Okay, and that's the end of the problem.